Let me find the proper place to stand. Okay, so hello everyone, welcome to this talk, Sailing Java 16. And as we were properly introduced, yeah, Java celebrated unofficially or maybe officially its 26th anniversary yesterday. And today I'd like to show you briefly the changes that happened to Java in version 16. So please keep in mind that this is not the surfing talk, so we are going to see some code demos, but this is also not a deep dive, meaning we won't see everything that happened to Java 16, right? Because like 3/4 is not like 3 hours, so we don't have that luxury. So shortly about me, yes, I'm self-employed as a remote freelance software gardener. Software gardener means that I have read the Pragmatic Programmer book, and maybe you should too. I blog every now and then at my blog page, softwaregarden.dev. I also work as a trainer from time to time. Yeah, this is me. So I've been doing Java. I've been with Java since version 1.3. And even when I go on holiday, provided there's a holiday, Java is somewhere behind me, right? So it's really difficult to get rid of old habits, so to say. And the question is, who are you? So please remember, we have this Discord chat, or maybe you see another chat window. Please remember that this chat window is for you to share your comments, to introduce yourself, to ask your questions, and so on. So if you have any questions, please don't wait till the very end of the presentation. Just type them right away, all right, in the chat window. And please remember that everyone is just a human being, and we have the right to be mistaken, and so on. So please keep that in mind and verify things on your own. Just don't trust random people on the internet, right? And so Java 16 was released like 2 months ago. And we even saw like 16.01 released in the meantime. So what has changed in this version is about to come. But now there's this very first question people keep asking themselves, or there are many myths or fallacies. Shall we migrate to Java 16 or stick to the latest LTS, like long-term support version? And it actually depends, right? This is the best answer I could give you as a consultant. So in general, if your software runs on Java 16, then why not, right? You should be trying to keep with Java and use the latest possible version and production, if that's possible, if your libraries support that, if your frameworks don't support that, sorry. And if you, for example, don't have frameworks or libraries which are relying on, for example, features that got removed from Java 9, then of course you should keep moving forward and forward. And maybe, of course, we shouldn't be using preview features in production or like incubator modules. I mean, sometimes it's even needed. Sometimes it's nice, but it's not always the case. So maybe it's worth not doing that, not being that eager. It's just please remember the actual meaning or misinterpretation of long-time support. So I very much like quoting Ron Pressler, I believe, here on this. So LTS is a mainly business term, right? So it's nothing about technical stuff and so on. And there was even a few days ago a very nice message from Mr. Reinhold. And yeah, I won't read it all. It's just, it says, mainly speaking, that if a version or release is LTS or not is most of the time completely irrelevant, right? So this is a business term like support and so on and so on. It's not about technical stuff. And it's like, LTS and the non-LTS versions are equally stable and so on. So please let me say that and say that aloud, that neither LTS versions or preview features are kind of like, I don't know, monkey soft or banana soft or anything like that, right? They are stable and as robust as any other version. So why wait if you can jump on this wagon and try using new features, for example, or even better said, like the performance improvements from latest versions, like, for example, new garbage collectors, new meta space, and so on and so on. So coolest features, according to me, this is my subjective list of Java 16. So of course, records, right? Then we have pattern matching with instanceof. Then we have this illegal access, switch to deny coming from project Jigsaw. And then we have second preview of sealed classes, which are supposed to be production ready in Java 17 this September. And there are also other changes from Valhalla and Panama. Of course, there are many more changes. There were 17 jobs in total. We're just going to cover some of them more or less briefly. And the agenda for today is that we'll try to do first the other things in records, because I already gave a talk on records on GD, I believe, or maybe it was for developers, sorry. And then if we have time, we'll scratch records too. If not, if you have more questions regarding like the earlier features, we'll stop there and cover these other features in the first place. Okay, so the first change, first JEP, and now we have it as a standard feature. It was introduced in Java 16 as JEP 396. It strongly encapsulates JDK internals by default. And what does it actually mean? So as we know, modules were introduced to Java 9, and they brought us warnings about this illegal access, right? So we run an application and it says something illegal access occurred and so on. And some people said, especially a few library or framework maintainers, that these are just warnings, right? And because they're warnings, they should be ignored. And the worst thing is that many more people followed this advice, right? So it was like, people weren't scared or weren't even afraid or didn't have a second thought what this illegal access means or what's the big deal. And it was like there was a new flag or new switch, -- illegal - access, and by default it was set to permit. And for many, this alone was a reason to say, oh, look, see, this illegal access is set to permit, so it's not that bad, okay? So it's permitted, so let's live happily ever after. It's just, it was promised from the day zero to be temporary, right? And this time has just finished with Java 16. So now it's switched to illegal access deny. And this is the new default, and worse, or maybe better, now it's deprecated for removal, meaning we can still switch this flag, but in the future release, one of the future releases, we won't be able to switch this flag to any other versions, because we have also like debug and warn for the options for illegal access, right? So let me just show you maybe what this illegal access is, okay? First, so we not talking like in a void, but we have like a real code to discuss. Okay, yeah, so what's this illegal access? Because reflection itself isn't that bad after all. I mean, sometimes we need to find at the runtime what the fields are there, what properties are there, and so on, provided they are accessible to us. And if they're not, we can do nasty things. We can go for like this, set accessible true on a field, or here as well, set accessible true. And this is the act, or I call it summoning the demons of deep reflection. So we want to try to reach for something that should be, in theory, according to OOP principles, unreachable to us, right? So we commit a crime against OOP. And when we run this short demo, it shows, yeah, this is exactly what happens, right? With Java 16, with the defaults, right? See, so now it's because this was switched to deny, now you cannot just run this program, it will blow. So what should we do about this, right? So what to do? So the best thing would be to stop using set accessible, basically, and make sure your vendors stop using it as well, and stop violating OOP if possible. Because why do you need to get like byte values like this, right? It's ridiculous. We should rather go for something like a value field and then get byte, right? We should recognize we're handling a string, which we do anyway, and so on. So this is how we should get not this one. We should have this on input, right? Of course, and get bytes and so on. So this is how we are supposed to get bytes from string. And the same applies here to for example, instance. So we shouldn't be calling set accessible. Instead, we should get seconds, maybe nanoseconds if we care about them, and so on. This is what we should be doing. If we can do that, then we can like switch this access on, or say, okay, I'm aware of this, please enable this anyway. So we can go for something like this, I believe. Yeah, so we can for example, run this code like this. That should be the terminal window or not. Let me just check. Let's see if it works. No, sorry, it's not that. Maybe it's this one. Yeah, it's still sorry, because it's It's Java, sorry, 17, whoops, sorry, SDK use Java 16 open. Right, and let's see again. It's still, sorry, I missed something. Access member string. Maybe I've changed the code. Okay, let's just remember that we can go for, if we can set this illegal access debug, then it will record every access of this. Sorry, every violation of this illegal access, and then we can switch to this add opens. I just think maybe let me do that in this run configuration. That should be maybe simpler. Modify run configuration and not program arguments, but VM options, add opens. Let's try again and let's run it. Oops. What the heck is going on? String, yeah, private final, but it should be open, right? You see, it's that problematic. So with Java 16, I mean, the demo goats are not with us today apparently, and the last thing you can go, you should do is going for illegal access permit. Let's try the illegal access permit here. Maybe it will work. Hopefully not as well, because this is the thing you shouldn't be doing. Yeah, okay, this one worked. We got this value and it says that illegal access occurred and so on and so on, and we shouldn't be doing this. Why shouldn't be doing this? Because then we keep producing the legacy code for future generations, right? Because this might not work in the future. And now let me just show you that briefly, because I'm not sure if the name was set properly or not for this JEP, but there is a JEP 403. Sorry, it didn't work. Numlock 403. And this 403 says that it should be strongly encapsulated, like in total. And you see, it's proposed to target Java 17. So it might be that the thing won't work in Java 17 at all. I mean, setting this illegal access deny or any other version, meaning that we should first, before hitting Java 16, either get rid of this set accessible true, or first go for all these add opens and illegal access set to debug or warn can help us with that. I talk more about this in my talk on migrating to Java 11. Okay, let's go then to pattern matching with instanceof or for instanceof. It was introduced, in JEP 394, and this is the code we all know, I believe. First, we want to see if this object is an integer, and if it's an integer, then we want to kind of like create an alias, right? And then we need to cast it here, and then we create this alias, and you can see integer, 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 and it's pretty ceremonial code. So what about doing this like this? Okay, so we can just, if we match it's an integer, we just say, okay, it's an integer. I just name it as an alias like this, and I put this alias here instead of this whole line above, and this is it. Like this allows us to like save these lines, which are pretty ceremonial, right? Because compiler knows here already that we are in the scope of this if we are handling an integer anyway. So some call it that it's a smart casting, and I like actually this description, and it can be used on not only in if statements. For example, see, I can like do this casting of a string, and I can alias it, and then thanks to this like the laws of secret breaking, shortcutting, and so on, I can then keep using this alias. So I can have, as you can see, just one single concise line instead of using like casting here or so on, or using like an if inside, right? And of course, these local variables or these aliases aren't implicitly final. This is one of the changes, I believe, from the preview features, and they are only visible, of course, in the scope they declared, and they shadow field names in case we have field names. So there should be a demo as well for that, and hopefully, let me just check if I didn't mess the JDK. No, it should be 16 open. Okay, so instance of with pattern matching. See, so we have a field here, a long, and this long is not used this because I am using here a long as an alias, which is, and this a long then assigns 42 to this local alias, not to the class field or object field, right? So we should remember that. And of course, there's this code like this. So I can create a method, who are you, and then toss various objects to this method, and then I can easily and nicely see what's actually happening inside this method, right? So if it's a serializable, I can just print out that we are handling a serializable, right? And then in subsequent checks, I can check if this is a string which has at least 3 characters, or if it's a positive integer, or if it's a long which has 1 digit only, right? Something like this. So let's run this. Yeah, see, so this is how it works. It says that pretty much everything is serializable in this very case, and then we are checking that we have a positive integer, serializable 777, which is, I believe, a long, but it's not a single digit long, and so on and so on. That's why the other thing wasn't printed. And then we have also other checks and so on. We also demonstrate, yeah, like this is another final thing. And voila. So this is a nice way to save a line from every pesky if statement when you're using instance of. And there are plans, and of course, there are even already, if I remember, JEPs targeted towards Java 17. So we should have pattern matching with switch expressions and switch instructions. So we'll be able to not only match the types using instance of, but also using switch or instruction or expression. There's a nice document describing that. For time being, we don't have, or we're not expecting like this deconstructors, like unapply from Scala, for example. That's something that should come to Java later on. And yeah, of course, this feature can be very useful with records in the future, as I said, with the constructors. Okay, so there's this concept of preview features in Java, right? So there's JEP 12 describing that, how it works. So in theory, it's about, -- enable -preview. And I'm not going to cover that in details. I did that in other talks. So let's forget that. It's just, let's not forget that. Let's skip that. Let's skip that. If you really need to, you can find these other talks or send me a DM on Twitter or Telegram. And the seed classes is just one of these preview features, right? So maybe we shouldn't be using them in production for Java 16. Let's wait for Java 17 when the thing becomes standard. Yeah, so currently it's JEP 397. And what's the idea behind sealed classes? So sometimes, especially if you maintain a classes or like a few classes, like even a whole hierarchy of classes or interfaces, you just want people like the other developers or consumers of your library just to use them, not to extend them. Like you see that in this very case, inheritance is really bad. Okay. And you just want to have this type as, I don't know, method parameter or return type or a field type, something like this. And so we don't want to like use final because, for example, there might be like, I don't know, other things preventing you from using final, I don't know, like proxies or something like this, although that might not be the best case. But you don't want to use final, and you can't use final, for example, you can't use final on an interface, right? Because interface is supposed to be implemented. And sometimes you want to have classes which are like, I don't know, base classes for the other classes of yours. That's why you can't use final, because they meant to be extended. Only you want to say that I know who should extend this class, not everybody else, right? And also we sometimes can't and don't want to reduce the visibility from public because we want these classes to be public. I mean, we want them to be visible, only we don't want anybody to inherit from such a class, right? So now we see that the concept of visibility and extensibility of a class like become two orthogonal concepts, like they shouldn't depend on each other. And the current rules, of course, with public and final stay in Java, nothing changes here. It's just now we have a way to prevent bad or intended code reuse by inheritance. Please remember, my friends, that inheritance isn't bad itself. It's just sometimes it's badly used because of the people should be using composition, and instead they go for inheritance. But it doesn't mean that inheritance itself it's inherently bad. I mean, OOP relies on composition and inheritance as well. And I have prepared this little, this is a UML diagram for you. And let's focus on this diagram for a moment. So we have this library, right? So we are the maintainer or the author of this library, and we have this type in our library, and then we have like another type implementing this, and like I don't know, like a abstract base implementing this, and then we have two subsequent classes which go even further. So this is our beloved inheritance tree. And we want to allow these green arrows for implementation inheritance, because this is like the permitted inheritance. We say that this is permitted inheritance, but then we want to seal this whole library or this whole tree of inheritance, this whole hierarchy of classes. And we don't want to allow these red arrows. So people shouldn't be able to extend or implement these classes or interfaces we've just sealed. We only want them to use them I don't know, as a field classes or return types. And of course, they can be only used if they're visible, like public, for example, right? So this is what we want to achieve. And this is the code that does it should be working exactly this way in Java 17. We'll see. This is what we have for Java 16. So for an interface or a class, because sealed classes is not only about classes, it's like a shortcut, right? It's for classes and interfaces. So we have a sealed interface, okay? And then we say that this library type should permit, this interface permits like two descendants, two children, for example. And we have this type, and we have this no-op library type. And then we go for this sealed again. For this abstract class, it has to permit its own children. And the thing is, if you are in a sealed inheritance tree, then everything needs to be either sealed or either final, or can be like non-sealed, which means I'm like giving up sealing, and now everybody can extend or implement me, right? So this is how it works. We have this sealed here, and then we have the list of permitted types here. And of course, it doesn't apply to final, because final is like sealed with no children, okay? So final doesn't have this permits list. And this is to prevent something like this from working. Let me, maybe we'll see that in the code. Maybe it would be better. Where is this sealing library type? Yeah, it's here, okay. Right, so this is exactly the code, as you can see. And this doesn't work because I cannot extend this class because it's sealed and I'm not permitted. I'm not listed in this permit clause. And I also can't implement this library type because, again, I'm not permitted to do so. What I can do, though, I can use these types, as you can see, as a field type or as a method parameter. It's going to work just nice. And so this is okay. And one thing, though, it works if you don't have modules. It works only within the scope of the same package. If you have modules, it works within a whole module, right? And if the classes or interfaces are listed in the same, in the very same file, then we can skip this permits, and it then gets inferred. Like, so if it's in the same source file, then it doesn't have to be listed in permitted, provided all the descendants are in exactly the same source file. So if when we start mixing like this file and other files, then of course we have to go for explicit permits list as well. Okay, so warnings for value-based classes. We still have 15 minutes. Okay, so this is a standard feature, right? Introduced in Java 16. And what are these value-based classes, or these warnings, better said? Let's talk about this for a minute. So there's a thing that's going to happen to Java. It's called Project Valhalla. And it's about bringing us a concept of like a value-based class or value objects, or the name differs sometimes. So the idea is to have classes without headers, without identities, objects without headers and identities. So they are just like what we care about them is only their value, the thing they carry inside, right? So this is the idea, like when you have, like, for example, primitive types like integer, float, or Boolean, we don't synchronize on these primitives. We don't, I don't know, we don't use constructors. We just use the syntax, of course. And there's a thing like auto-boxing, but let's leave that apart for a minute. So as you can see, if you have a number like 42, we don't care if this 42 is like this 42 and another 42. 42 is 42, and that's it when it comes to primitives. And it's like a gross oversimplification, but it's about the same as about value-based classes or value objects. So they have only value, they don't have identity, meaning we shouldn't be comparing the identity using double equals. We should be like compare only what they carry inside using the equals method, right? This is the Java's idiom for do that. In a way, they could be thought as a wrappers for these things they keep inside, although it's not like legitimate description, and they should be immutable. When you have, like, I don't know, an angle and as a float, right, in degrees, for example, then we don't like mutate this very angle. We can create another, we can, I don't know, add a +10 or something like this, but the original value remains there and it's immutable and it's still there as long as it's reachable and not garbage collected. And these value-based classes should be created using factory methods, not constructors. And because of these things above, they should be able to be substituted when they're equal. So as I said, when you have a 42, it doesn't matter if it's like this 42 or another 42. 42 is 42, and that's it. So we don't compare them using this double equals. There's a nice description of value-based classes because the definition changed slightly recently, and we have some examples. So these are all these integerish types, right? This whole family of these types, optional, optional double, optional int, and so on. We also have many classes from Java time package, and also the classes implementing or using the implementation used in like methods like list of, list, copy out, set of, and so on. And there are also others, and in theory, it should be everything that's annotated as a value-based class, at least for time being. And because of this nature, the nature of this object shouldn't be compared. I can't stress it enough using double equals. They shouldn't be created using constructors, and they shouldn't be used for synchronization, right? This warning coming in Java 16 is to make people or developers aware that such thing as a value-based classes might happen in the future. So we start emitting warnings again, and hopefully they won't be ignored like the warnings from Project Jigsaw, like this illegal access. And it means that the constructors are now deprecated for removal, that we shouldn't, like, we should see warnings about synchronization when we switch this flag on. Or this is the type of this warning from the compiler. And if we are using like third-party code, which is doing these crimes of synchronization, then we can switch to additional flags, either one to like make this program go belly up, or for two, which is like log everything, every like synchronization of such a class. So let me show you a brief demo on this. Yeah, so this is it, right? As you can see, the constructor now is, I hope it's seen, there should be like a red line going through this long. It means that this constructor is now deprecated for removal. So see, this is one of the warnings, like, besides unnecessary boxing. So this call is okay because we are using factory method. And then when you see synchronizing on such a type, it says it's an attempt to synchronize of an instance of a value-based class. And now what you can also do is just you can pay attention to what you have in what the compiler is trying to tell you. Yeah, let's compile this class and see we have two warnings. So first warning is that, yeah, this constructor is going to be removed. So this is the warning, it was seen here. And another thing is that we're using this object for synchronization, see? And this is a synchronization warning. So it might not work with like all the build tools. It might require some updates and so on. And if we run this code, let me run it. Let's see if this one works. Yeah. And because I've added these flags, you can see that in here, hopefully. Yeah, see, I've added these warnings, right? So now every attempt to synchronize on this is going to be seen in standard output. So JVM, like the hotspot, detects that and prints us for us as well. And of course, if we have like third-party bytecode and we don't have the source code, we can use JDepreScan to scan these dependencies to tell us if they are violating these rules against the value-based classes or not. Okay, so seems that we have like 10 minutes for records. So let's go for records briefly because they might be one of the biggest game changers when it comes to Java. I mean, we had classes, we had interfaces, then we had annotations and enums added in Java 5, but they weren't as big possibly as records, because records are a new kind of type declaration and they are kind of a restricted form of a class. I like to think about them like a cousins of enum. Like enums are classes, are objects, right? They are restricted, and records are also restricted, only in a different flavor, so to say. And they always extend Java lang record, and they are meant to be transparent carriers for immutable data. And this is how we declare them. So instead of using class, we go for record, then we have the name or the type, and then we have so-called header. And in this header, we are going to say the type and the name, the type and the name. And these are going to become our fields, actually. And we're also going to have methods to access the values stored here during the constructor call. And these accessors are going to have exactly the same names without any prefixes like get or is or was or has been or whatnot. So what records have? Records have a name, they have their components, although the list is not strictly required. And these components become private final fields. So they have generated accessors, they have full canonical constructor, meaning I can call a constructor which has all these components for me. They also have generated equals, hashcode, and toString using all these components. That's important to remember. And they also have a body, and the body might be empty, as we saw in the previous case when we don't want to do anything. What records can? They can redefine constructors. They can have their own implementations of generated methods. For example, you don't like toString method because something, or you don't like equals method because you are forced to use like mutable collection, for example. Then you override equals method and so on. And by the way, they should still keep the contracts alive, so they shouldn't be violating the invariants or rules or whatever they're meant to be. We can have extra methods. We can have static fields and static methods, and they can implement interfaces, and they can be even generic, because why not? What they can't do, they cannot extend classes, or they cannot be extended. They cannot have any setters. I mean, we could have, in theory, a method which is mutating a mutable field under the hood, but it's not like a setter for this component or the field, right? Because the field itself is final, so any setters won't work in this way. And they cannot have any extra instance fields like super private, for example, like you can do in case classes in Scala. And they cannot have less visible canonical constructors, meaning if a record is public, we cannot define a canonical constructor, which is, for example, package default. And they cannot declare native methods. They cannot reassign components in compact constructors. So in theory, sorry, let me go. I've lost this slide. In theory, what they shouldn't do is just they shouldn't put the contents, the data they keep inside at any risk, right? This is what they shouldn't be doing. And records, please remember that records are not Java beans. They just pointers with accessors. And these pointers are final, right? And the nice way of thinking of them is like named tuples. So they are just tuples, but unlike, for example, anonymous tuples in Scala, they have a name and a type, therefore, and that's important. And they're not deeply immutable, because they're immutable only at shallow levels, right? So if you toss a list to a record, then this list is mutable. If it's an array list, for example, only we cannot replace it with a new array list. And sometimes, therefore, we need to require, we're required to override equals and hash code, although I would say I would first try to remove immutable components from the records. Records are very nice to be nested, like static classes, and they're very nice for streams, like intermediate results, and so on and so on. Let me just show you that maybe in code. Let's have at least one demo of records. And yeah, so there's another project with records. Yeah. So maybe you know this complex class from university, right? so which has like lives in 2 dimensions, for example. And this is how we use this complex class. And now instead of declaring it in a like Java binish way, so to say, you see I can multiply these complex numbers, for example, or I can print them out. What I can do though is just I can declare them as a record. You see, it's a record, and then I have these 2 parts, real and imaginary, and I can add like extra methods like add, subtract, and multiply. Just please in mind that these methods don't mutate the state of this record. Instead, they just yield another result, right? And then, for example, I can override the toString method because this is the format I like. If I don't have this method overridden, then when I run this demo, yeah, this is the default format of toString for a record. Yeah, so it's a name, and then all these components are listed with their values in square brackets. So if you want to override, for example, a toString or need to override equals or hash code, this is the way you do that, and this is the result. And maybe the nicest thing is about these nested things. See, this is a brief demo of using team collectors. It's just like team collectors are not very important in this very case. It's just to make this demo work. What I have to do is I need to have this like oversimplified binish type, right? So as you can see, I have a stream, and because of I want to have only one pass of this stream, and therefore I need to create like a class for intermediate results, because storing data like an array or something is really a bad idea because you don't know what's what. You just give up, you know, the names and maybe even types sometimes. So to make this demo work, I need to have that binish type, right? So in a single pass, I can calculate the sum and the count of the elements of the stream, right? And the thing is, this code is pretty dull, right? It's nothing super duper spectacular. It's oversimplified. I have even public fields. I just have a constructor and I have toString method. So why not basically, why not try to do this in a single line? And this could be just declaring this record like this. So I declare this record. I say it has 2 components with exactly the same names, count and sum. And when I run this, the results should be the same. Yeah, this time it worked. They are exactly the same. It's just there's one extra thing I want you to see in case we miss that. I didn't declare this record like, as you can see, after this class, right? Or as an inner class, because it's a static class, or it could be in separate files or something. If I need this intermediate type for result only in this method, in this very case in main method, then I declare the record inside the main method. And that's the thing. Records can be, that's why we don't have anonymous records and or tuples, and we actually might not even need them because we can declare instantly this record type, which will serve us till the very end of this main method. So yeah, this is it. Of course, records are very useful with other features like instanceof, and they are very useful with sealed hierarchies. And in the future, most probably they will support the construction with pattern matching. And there's more on records on my blog page if you're interested about records. Like I even tried to kind of make records and Lombok place nicely together, and this changes from version to version. So really sick experiments, but if you have some time, why not? Please, my friends, always provide your feedback for everyone, not just me, not just for developers, just every meetup or presentation, see for every speaker, because this is still not live, unfortunately. I would like to ask you to fill this little poll or provide the feedback, fill the feedback form from PROIDEA, from the organizers of 4Developers, whatever suits you. This one is anonymous, so I don't know your name, I don't know anything. It's just like 4 simple questions. This is it for today. Thank you very much. I hope I just made it in time. So again, this is my Twitter and Telegram handle. So if you'd like to send me like direct messages, questions or something privately, why not? You can do that. This is my personal blog page. This is the link for this presentation, and this is the code so you can clone it from GitHub and experiment on your own. Thank you very much. Dziękuję bardzo. And I'm not sure if we have any questions. Back to the studio. Do we have any questions?